Hello there, and welcome to the Sleep Well channel. I am so glad you have found your way to this quiet space to let the day dissolve and your thoughts soften. Tonight, our journey takes us to the most distant shore imaginable. We are not just looking at the stars. We are drifting back to a time before them, before galaxies, before light itself had a clear path to travel. We will journey to the very beginning, to the first quiet moments of the universe itself. There is nothing you need to do now but rest. Let your breath soften, your shoulders release, and your body grow heavy as if sinking gently into a calm, dark sea. Your only task is to listen and to let these wonders carry you toward the peaceful shores of sleep. And just before we begin, if these calm explorations help you unwind or give you a gentle way to end your day, consider liking and subscribing. It helps other sleepy souls find their way to this quiet corner of the world too. Now, if you're ready, let us begin. The universe did not begin with an explosion in space. It began with the unfolding of space itself. We often imagine the Big Bang as a firework in a dark, empty room. But there was no room. There was no darkness. There was no space for an explosion to happen in. Instead, the Big Bang was the emergence of everything everywhere all at once. It was the sudden, breathtaking expansion of space-time and energy from a point of unimaginable density. Think of it less like a bursting bomb and more like the surface of a balloon being infinitely stretched in every direction. The galaxies that rush away from us today are not flying through space, but are being carried along as the fabric of space itself continues to expand. It is a motion so vast and fundamental it has no center. The beginning happened everywhere, and that gentle, cosmic unfolding, which started nearly 14 billion years ago, continues even now as you rest. There was a moment so early in the universe's life that our laws of physics do not apply. This first sliver of existence, known as the Planck epoch, lasted for a fraction of a second, so small it defies all human intuition. During this time, the universe was compressed into a space smaller than an atom, at a temperature of trillions upon trillions of degrees. Here, gravity, quantum mechanics, space and time were all woven together in a state we cannot yet describe. It may have been a quantum foam where the geometry of space and time shimmered in and out of existence, a sea of pure potential. Our science, our mathematics, our understanding of cause and effect, it all stops at the edge of this moment. It is the farthest back we can peer, not with telescopes, but with theory. And what we find there is a quiet, shimmering mystery, a point where all the rules that govern our reality had not yet been written. In that first moment, the four fundamental forces of nature were one. Today, we experience a universe governed by four distinct forces: gravity, which holds the planets in orbit; electromagnetism, which carries light; the strong nuclear force, which binds atoms together; and the weak nuclear force, which governs radioactive decay. But in the searing heat of the Planck epoch, these four forces were indistinguishable, merged into a single, perfect, unified force. As the universe expanded and cooled with astonishing speed, this symmetry broke. One by one, the forces froze out and separated, each taking on the unique identity it holds today. Gravity was the first to split away, followed by the others. This gradual separation is like watching water vapor condense into liquid and then freeze into the intricate, separate crystals of a snowflake. The universe we live in, with all its complexity, is the beautiful, fractured result of that first perfect unity breaking apart. We cannot truly ask what came before the Big Bang because time itself may have begun in that moment. The question seems natural, but it may be like asking what is north of the North Pole. According to Einstein's theory of general relativity, space and time are bound together in a single fabric. If the Big Bang was the origin of space, it was also the origin of time. In this view, there is no before, because the very concept of before and after did not exist. Some speculative theories imagine cycles of universes or a timeless quantum realm from which our universe emerged. But in the language of our own cosmic history, the Big Bang is the first word. It is the beginning of the story, the moment from which all clocks, all calendars, and all histories begin to measure. The question of what lies beyond that first moment remains perhaps the greatest philosophical mystery in science, a quiet question mark at the very edge of existence. The universe began in a state of almost perfect order. We live in a cosmos where things tend toward disorder. A hot cup of coffee cools. A sandcastle crumbles. This principle, known as entropy, is the arrow of time. Yet for this arrow to fly forward, the universe must have started in a state of incredibly low entropy, a state of near-perfect order. Imagine a box filled with gas. Its most likely state is for the gas to be spread evenly throughout. But the early universe was like a box where all the gas was inexplicably compressed into one tiny, perfect corner. This initial highly ordered state is what allowed for all of cosmic history to unfold. Every star that has ever burned, every galaxy that has ever formed, is part of this slow, irreversible journey from simplicity into complexity, from order into a richer, more structured form of disarray. Why the universe was born with such pristine order is one of the deepest puzzles in cosmology. It is the reason there is a past, a present, and a future at all. Our universe may be just one bubble in a vast cosmic foam of other universes. The idea of the multiverse suggests that our reality, with its specific laws of physics and its particular history, may not be unique. It could be just one bubble in a vast, frothing ocean of other universes, each budding off from the others, each with its own physical constants, its own number of dimensions, its own story. In this cosmic landscape, some universes might be barren, collapsing back on themselves in an instant. Others might expand into cold, empty voids. And a few like ours might have just the right conditions for stars, planets, and life to emerge. While we can never see these other universes, the idea arises naturally from some of our most advanced theories about the cosmos. It is a humbling thought that the entire sky of stars we see all of known existence could be just a single quiet island in an infinite archipelago of other worlds. And perhaps the most relaxing fact of all is that the simple existence of everything remains the deepest mystery. For all that science can explain about how the universe evolved from particles to protons, from gas clouds to galaxies, it cannot yet tell us why there is a universe at all. Why is there something rather than nothing? No telescope, no equation can yet touch this question. It hangs in the stillness of the cosmos, not as a problem to be solved, but as a source of endless wonder. The fact that you are here now, in a quiet room, breathing softly, a part of this vast and mysterious unfolding, is the greatest and most beautiful truth of all. The universe simply is. And within it, for this brief and precious moment, so are you. And so, from that first unknowable moment, the universe took its first true step, not as a crawl, but as a leap of impossible scale. In a fraction of a second so brief that it makes a blink of an eye seem like an eternity, the cosmos swelled from a size smaller than a single atom to a vastness that would dwarf galaxies. This process, so swift and so total, has been given a simple, gentle name: inflation. This was not an explosion, pushing matter outward into an existing void, but the very fabric of space itself expanding at a speed far faster than light. It was a silent geometric blossoming, a moment when the universe unfurled its own dimensions, creating the grand, empty stage upon which all of cosmic history would later play out. This brief, powerful, yet strangely elegant expansion smoothed the wrinkles from the newborn cosmos like a hand gently smoothing a sheet of silk, creating the vast, uniform canvas we see today when we look out at the grandest scales. It was a moment of profound transformation, the universe's first deep and silent breath, inhaling a point of infinite density and exhaling a cosmos. The stillness you feel in a quiet room, the immense dark between the stars, the very scale of existence, all of it is a legacy of this ancient silent stretching. The universe, in its very first act, chose not to build slowly, but to become vast in an instant, laying the foundation for everything that would follow in the long, quiet eons to come. This period of inflation, though lasting for a time almost too short to measure, set the stage for the next 13 billion years of cosmic evolution. It was the quiet, unseen hand that shaped the destiny of every star and every galaxy, a fleeting moment that defined the shape of eternity itself, a whisper that gave birth to the immensity of the night. This sudden, breathtaking expansion explains why the universe appears so remarkably smooth and uniform on the largest scales, a puzzle that long troubled astronomers. Without inflation, different regions of the early cosmos born far apart from one another would not have had time to interact and reach the same temperature. One patch of the sky might have been vastly hotter than another, creating a lumpy, chaotic universe, unlike the serene and balanced one we know. Inflation solved this horizon problem by taking a single, tiny, connected, and uniform region and stretching it to an immense size before these differences could form. Imagine a small, perfectly smooth droplet of ink suddenly expanded to fill an entire ocean. Every part of that ocean would still share the same uniform color. In the same way, the universe we see today, with its near-perfectly uniform temperature in all directions, as measured in the cosmic microwave background, is a magnified image of that first tiny, harmonious patch. It is a quiet testament to a moment when the cosmos was stretched so thin and so fast that all its initial wrinkles were ironed out, leaving a serene, balanced foundation upon which galaxies could later form. The gentle, even glow of the night sky, when viewed with the most sensitive instruments, is the echo of this ancient smoothness, a reminder that the universe's history is one of both violent expansion and profound underlying peace. It is as if the cosmos in its infancy was granted a moment of perfect stillness, which was then preserved and stretched across the ages, a silent promise of the harmony to come. And in that magnificent stretching, something truly magical happened. The tiny fleeting jitters of the quantum world, the very uncertainty at the heart of reality, were magnified to cosmic proportions. In the strange and beautiful realm of quantum mechanics, even the most perfect vacuum is not truly empty. It is a quantum foam of virtual particles and energy fluctuations flickering in and out of existence, for moments too brief to measure, a constant, gentle hum beneath the surface of reality. During inflation, as the fabric of space itself expanded at this incredible rate, these microscopic fluctuations were stretched along with it. A ripple smaller than an atom, a fleeting tremor in the quantum field, was suddenly magnified into a wave that could span thousands or even millions of light years. These stretched out fluctuations became the seeds of all future structure. The slightly denser regions born from a random quantum flicker would later possess just enough extra gravity to begin pulling in the surrounding gas and dust. From these infinitesimal seeds, the first stars would one day ignite. The first galaxies would swirl into being, and the great cosmic web of filaments and voids would eventually take shape. It is perhaps the most beautiful and profound idea in all of cosmology that everything we see today, every star in the sky, every planet in orbit, even your own body, owes its existence to a random microscopic tremor. At the very beginning of time, a whisper in the quantum foam that inflation amplified into the grand and silent symphony of the cosmos. The invisible engine that drove this incredible expansion is thought to be a hypothetical energy field that permeated all of space in that first instant, a field known simply as the inflaton field. Imagine a field holding an immense amount of energy in a highly unstable, high-energy state. This energy created a kind of cosmic anti-gravity, a powerful repulsive force that pushed space apart with unbelievable strength. For a brief, fleeting moment, this field dominated the universe, its energy density remaining constant even as space expanded, driving the exponential growth of inflation. Then, just as suddenly as it began, the field decayed like a ball rolling gently to the bottom of a valley, settling into its lowest energy state. Its vast, stored energy was released, transforming into the hot, dense soup of particles and radiation that would become the universe we know. It was as if a great cosmic spring had been wound to its tightest possible point, and then suddenly released its stored potential energy, unfurling into the creation of all matter and light. While we have never directly observed the inflaton field, the evidence for its existence is written across the sky in the breathtaking smoothness of the cosmos and in the subtle, beautiful pattern of the seeds that grew into galaxies. It is the ghost of an ancient force, the quiet, powerful engine that turned a single point into a universe. And the end of inflation was not a sudden, jarring stop, but a graceful and gentle transition known as reheating. As the inflaton field settled into its final resting state, it released its vast reservoir of energy, flooding the newly expanded cold and empty universe with a firestorm of elementary particles. It was in this moment that the universe truly became hot. The energy that had been locked away in the structure of space itself was converted into the kinetic energy of matter, creating a seething, primordial soup of quarks, electrons, and photons, all at an unimaginable temperature. This was the true hot beginning of the Big Bang, as we often picture it. Inflation was the silent, expansive prelude the creation of the grand stage. Reheating was the moment the actors arrived, and the cosmic play began in earnest. The universe, which had been cold and empty during its rapid expansion, was now filled with a radiant, energetic glow. This warmth, the leftover heat from that first moment of transformation, has been cooling ever since, and it can still be detected today as the faint, gentle whisper of the cosmic microwave background. It is a direct link to a time when the universe was filled with a light so brilliant and so pure that it contained all the promise of the stars that were yet to come. You are made of matter that was born in that fire, forged in the graceful and quiet end of that first great cosmic expansion. The universe was now ready for its next chapter, a journey from pure energy into the first stable forms of matter, a story that would unfold in the shimmering, vibrant fog of its earliest moments. As the universe settled from its breathtaking inflationary expansion, it was filled with a substance unlike anything that exists in our world today. This was a time before atoms, a time before even the protons and neutrons that form the heart of atoms had taken shape. For the first few microseconds of its existence, the cosmos was a seething, vibrant, and perfectly smooth soup known as the quark-gluon plasma. In this extraordinary state, the universe was so intensely hot and so densely packed that the fundamental building blocks of matter, the particles we call quarks, and the particles that carry the strong force that binds them, the gluons, roamed freely. They were not yet confined within the familiar structures of protons and neutrons, but existed as a nearly perfect, frictionless liquid, flowing without resistance. Imagine a drop of perfectly clear water. But instead of water molecules, it is made of the very essence of matter itself, shimmering at a temperature hundreds of thousands of times hotter than the fiery core of our sun. This was the universe in its most elemental and untamed form. It was a silent, radiant ocean of pure potential, a time when the rules of matter were still fluid and the seeds of the elements had not yet been sown. The very substance that now makes up the world around you, the carbon in your bones, the nitrogen in the air, and the oxygen you breathe, once existed in this free, unbound state, a fleeting and beautiful memory from the universe's very first heartbeat. This primordial soup was a chaotic and wondrous particle zoo, a place teeming with activity. Alongside the familiar quarks and electrons that form the basis of our world, the intense energy of the early universe allowed for the creation of a whole host of exotic, heavier particles. These were strange and unstable particles, muons and taus. Strange quarks and charm quarks, particles that are so fleeting they exist today for only the tiniest fractions of a second in our most powerful particle accelerators like CERN's Large Hadron Collider. But in the infant cosmos, they were commonplace, flickering in and out of existence in a constant shimmering dance of creation and annihilation. It was a world governed by pure energy, where a flash of light in the form of a high-energy photon could spontaneously transform into a pair of matter and antimatter particles, only for those particles to find each other again, collide and vanish back into a burst of pure light. This vibrant, shimmering state lasted for only a few microseconds, but it was a crucial and formative chapter in the universe's story. It was the time when all the fundamental ingredients of reality were first mixed together, a rich, energetic broth from which all future complexity would eventually and quietly emerge. The universe was alive with a kind of energy we can barely comprehend, a silent flickering storm of creation that laid the essential groundwork for the quieter, more stable cosmos we now inhabit. And it was in this early fiery inferno that a great cosmic battle was waged, a battle between matter and its mirror image, antimatter. For every particle of matter, like a quark or an electron, the searing energy of the Big Bang created a corresponding antiparticle, a perfect twin with the opposite electrical charge. When a particle met its antiparticle, they would instantly annihilate each other in a brilliant flash of pure energy. And in reverse, these flashes of energy could just as easily create new particle-antiparticle pairs. For a brief, perfect moment, the universe was a place of absolute balance, with the forces of creation and destruction happening at an equal and constant rate. But this perfect symmetry, this beautiful sterile balance could not last. If it had, every single particle would have eventually found its antiparticle partner, and the entire universe would have annihilated itself into nothingness, leaving behind only a sea of cooling, featureless light. There would be no stars, no planets, and no one to wonder why. The very fact that we are here today, that the universe is filled with galaxies and not just photons, is the most profound proof that the balance was broken. Something in that first crucial moment tipped the scales ever so slightly in favor of matter. The mystery of why matter won this cosmic battle against antimatter is one of the deepest and most significant unsolved puzzles in all of physics. This puzzle is known as baryon asymmetry. For some reason which we do not yet fully understand, for every 1 billion pairs of matter and antimatter particles that were created and destroyed, there was one single extra particle of matter left over. It was an infinitesimal imbalance, a cosmic rounding error of just 1 part in a billion. But it was this tiny flaw in the universe's initial perfection that made all the difference. As the universe cooled and the frantic dance of annihilation slowed down, all the perfectly matched pairs vanished in flashes of light, leaving behind only that tiny surviving surplus of matter. Everything you see, everything you are, everything that has ever existed is made from that leftover fraction. The stars in the night sky, the solid ground beneath you, the very air you breathe. It is all the beautiful, tangible remnant of that ancient lopsided victory. Scientists still do not know what caused this crucial asymmetry. It may have been a subtle difference in the way certain exotic particles decayed, or perhaps the influence of an unknown force that has long since faded from the cosmos. Whatever the reason, we live in the universe that was left behind, a cosmos built from the quiet, miraculous triumph of something over almost nothing. And as this grand drama of matter unfolded, another type of particle began its long, lonely, and silent journey. Neutrinos, the ghostly, nearly massless particles that barely interact with anything at all, were also created in vast numbers in the primordial soup. In the universe's very first second, while the cosmos was still a dense, opaque fog for light, it was already completely transparent to these elusive neutrinos. They decoupled from the rest of the primordial plasma and began to stream freely through the expanding space, almost entirely unaffected by the matter and energy that still swirled around them. These relic neutrinos from the first second of the universe are still traveling through the cosmos today, filling all of space in a faint, invisible background, a silent testament to the universe's earliest moments. They are older than the light from the first stars, older even than the first atoms. Detecting them directly is one of the greatest challenges of modern physics, for they carry with them a snapshot of the universe at an even earlier time than any form of light can ever reveal. As you drift toward sleep, as you lie here in the stillness, trillions of these ancient ghostly messengers are passing silently and harmlessly through your body, through the walls of this room, and through the entire earth, carrying with them a physical memory of a time when the universe was less than a single second old. They are a quiet, invisible river of time flowing from the very dawn of creation, connecting you directly to the heart of the Big Bang. Out of the shimmering, featureless chaos of the quark-gluon plasma, the first hints of a more familiar and structured reality began to quietly emerge. As the universe continued its relentless journey of expansion and cooling, it crossed another critical threshold. When the cosmos was just about 1 microsecond old, the temperature dropped to a point where the free-roaming quarks could no longer exist in isolation. The strong nuclear force, the most powerful of nature's forces, which had been weakened by the intense heat of the beginning, now became overwhelmingly powerful, acting like an unbreakable tether. It began to bind the quarks together in inseparable groups of 3, forming the first stable composite particles of matter, the protons and neutrons. This was a moment of profound cosmic crystallization, a fundamental shift in the state of the universe. The fluid, untamed energy of the quark-gluon plasma froze into the first permanent durable particles of matter. Imagine a swirling mist of water vapor suddenly condensing into the first solid, tangible ice crystals. This was a transition of similar significance, but happening on the most fundamental subatomic level. The universe was beginning to build. These first protons and neutrons were not yet atoms. They were simply free-floating, positively charged nuclei in a vast hot sea of electrons and light. But their formation marked a pivotal and irreversible step forward. The universe had created the permanent, durable seeds from which every atomic nucleus, every element, every star, and eventually every living being like you would one day be constructed. The soft, gentle substance of your own body began its long journey in this fiery moment of binding. This entire chapter of creation, the transition from a free soup of quarks and gluons to a sea of distinct protons and neutrons unfolded within the universe's very first second of life. It is a span of time so extraordinarily brief that it is difficult for the human mind to grasp, yet it contained one of the most important and foundational transformations in all of cosmic history. In that first second, the universe was still hotter and denser than the core of any star that has ever existed. It was a brilliant, opaque fog of particles constantly interacting, colliding, and changing. Light, in the form of photons, could still not travel far. Its path was a frantic, chaotic dance as it bounced from one free electron to another, unable to cross any significant distance before being scattered. The entire universe was filled with a uniform, radiant glow, but it was a light that was trapped within itself, unable to travel freely across the vastness of space. The cosmos was both intensely luminous and profoundly dark. At the same time, a paradox of light without sight that would persist for hundreds of thousands of years. But within that glowing, shimmering fog, the quiet and patient work of creation was well underway. The universe was patiently and methodically assembling the ingredients for a future that it could not yet illuminate, a future of clarity, structure, and form. During this first crucial second, the cosmic ballet of creation and annihilation continued, but now with a new and more stable cast of characters: protons and their antimatter counterparts. Antiprotons, along with neutrons and antineutrons, were constantly being forged from pure energy, and just as quickly they would find each other, collide, and vanish back into a burst of brilliant light. But because of that tiny, mysterious, and life-giving imbalance that had favored matter over antimatter in the preceding moments, a small surplus of protons and neutrons survived this final great annihilation. As the universe continued to cool, the tremendous energy required to create these heavy particle-antiparticle pairs became increasingly rare. The process of creation slowed to a halt, but the process of annihilation continued until almost all of the antimatter was gone for good. What was left behind was a stable, enduring sea of matter, bathed in a brilliant glow of leftover photons from all those final collisions. The final quiet victory of matter was now complete and irreversible. The universe had chosen its path, and it was a path that would lead to a cosmos filled with substance, a world you could touch, a sky you could see, and a ground you could stand upon. And in the final fleeting moments of that very first second, the universe set the fundamental recipe for its future chemical composition. As the temperature continued to drop, the constant frantic transformation between protons and neutrons began to slow down. In the hottest moments, energy was so abundant that they could flip back and forth between states with ease. But as the cosmos cooled, it became slightly more favorable for the heavier neutron to decay into the lighter proton than for the reverse to happen. This subtle preference, governed by the laws of physics, meant that as the universe froze into its final ratio, there were more protons than neutrons. The process settled at a ratio of roughly 7 protons for every 1 neutron. This simple, elegant ratio, set in stone in the universe's first second, would go on to determine the chemical composition of the entire cosmos for eons to come. It is the fundamental reason that today the universe is overwhelmingly made of hydrogen, whose nucleus is just a single proton, and a smaller amount of helium, which is built from a blend of protons and neutrons. This primordial recipe was written before the first stars ever shone a quiet mathematical decision made in the fading heat of the Big Bang. A decision whose consequences are still written in the composition of every star in the sky and every cloud of gas between them. The universe, at this stage, at the tender age of 1 second, was a place of immense and beautiful simplicity. It contained just a handful of essential ingredients, a vast number of protons, a smaller number of neutrons, an equal number of electrons to balance the charge, a sea of brilliant photons, and a ghostly background of neutrinos, all swimming in an expanding sea of space-time. There were no complex structures, no molecules, no chemistry, and certainly no life. There were just the raw, fundamental building blocks of reality, interacting according to a few simple, powerful, and elegant laws. There is a deep and profound sense of peace in contemplating this pure, early state of being. It is a reminder that the universe, in its very essence, is not chaotic, but ordered. It is a confirmation that the bewildering complexity of the world we see around us today, with all its richness and diversity, arose from a state of almost perfect, tranquil simplicity. As you let your own thoughts settle, as you let the complexities of your day begin to fade, you can perhaps feel a faint, distant echo of that ancient cosmic calm. It is a sense of returning to a simpler, quieter state of being, just as the universe did in its very first moments of existence, laying the foundation for all the wonders that were to follow. As the universe drifted past its first second of life and the last of the antimatter faded away, it entered a new and crucial phase of creation. The stage was now perfectly set. All the necessary ingredients were present, and for a brief, brilliant window of time, the entire cosmos transformed into a single, massive nuclear furnace. This remarkable period, lasting from about 1 second to a little over 3 minutes after the Big Bang, is known to science as the era of Big Bang nucleosynthesis. During this time, the universe was still incredibly hot, with temperatures soaring into the millions of degrees, easily hot enough for the newly formed protons and neutrons to overcome their mutual repulsion and fuse together. But it was also cooling rapidly as space continued to expand. This created a delicate, fleeting, and perfect opportunity for creation. If the universe had been too hot, any new atomic nuclei that managed to form would have been immediately blasted apart by the sea of high-energy photons. If it had been too cool, the particles would not have possessed enough kinetic energy to fuse at all. For just a few short minutes, the entire universe existed in a perfect Goldilocks zone for the creation of the first light elements, a cosmic forge operating on a scale that defies imagination. In this universe-spanning kitchen, the very first atomic nuclei were cooked into existence. The free-floating protons and neutrons, which had been set in their final ratio just moments before, now began to collide and stick together, bound by the unbreakable grip of the strong nuclear force. A single proton and a single neutron fused to create a nucleus of deuterium, a stable heavy form of hydrogen. Then 2 deuterium nuclei could combine to form a nucleus of helium-3, and those in turn could fuse to create the incredibly stable and tightly bound nucleus of helium-4, made of 2 protons and 2 neutrons. This process was remarkably efficient. By the end of this brief creative period, almost all of the available free neutrons had been swept up and locked away safely inside these new helium nuclei-like ingredients, being carefully measured and added to a cosmic recipe. A few leftover fusion reactions managed to create tiny trace amounts of lithium, the third element on the periodic table. But the process could go no further. The universe was expanding and cooling far too quickly. The density and temperature of the cosmos soon dropped below the critical threshold needed to sustain nuclear fusion. The cosmic furnace, which had burned so brightly across all of space, simply turned off. When the fires of creation went out after just a few minutes of activity, the fundamental chemical composition of the universe was set, a composition that would remain unchanged for the next few 100 million years until the first stars began to light up the sky. When all the cosmic dust had settled, the universe was left with a simple, elegant, and primordial recipe for its future. For every 10 protons, which are simply hydrogen nuclei, there was now roughly 1 newly formed helium nucleus, and only the most minuscule, almost immeasurable traces of anything else. This means that the matter in the early universe was composed of about 75% hydrogen and 25% helium by mass. This precise prediction, derived directly from the theory of Big Bang nucleosynthesis, stands as one of the most stunning and successful predictions in the entire history of science. Because, When astronomers look out at the most ancient stars and the most pristine, untouched gas clouds in the far reaches of the universe, places that have not yet been polluted by the products of later stellar fusion, they find this exact same ratio again and again and again. The chemical fingerprint of the Big Bang is written across the entire cosmos, a silent and powerful confirmation that our understanding of the universe's first few minutes is remarkably beautifully accurate. The helium that fills a child's birthday balloon is not just a light and harmless gas. It is a precious physical relic from a time when the entire universe was a single, sprawling, and short-lived star. This process of primordial nucleosynthesis stopped before it could create any of the heavier elements that are so essential for life. We know it. Elements like the carbon in our cells and the oxygen we breathe. This was due to a combination of unavoidable factors. The rapidly dropping temperature and density of the expanding universe was the main reason. But there was also a crucial bottleneck in the fusion process itself. There are no stable atomic nuclei with 5 or 8 nuclear particles. This means that adding a proton or a neutron to a stable helium-4 nucleus or trying to fuse 2 helium-4 nuclei together does not create a stable, lasting element. In the hearts of modern stars, this barrier is overcome through a slow, patient, and complex process called the triple alpha process, a delicate dance that requires hundreds of millions of years of steady, intense heat and crushing pressure. The early universe had only minutes. The great cosmic clock was ticking far too fast. The very expansion of space itself was the force that quenched the fires of creation, leaving the universe with a beautifully simple yet incomplete elemental palette. The grand and noble task of forging the heavier elements, the building blocks of planets and people, would be left to a later generation of creators, the stars. The universe, in its infinite wisdom, seemed to know that some things, the most precious things, required more time, more patience, and a quieter, more stable furnace. After these first few creative minutes, the universe entered a long, stable, but still intensely luminous phase. It was now a hot, opaque plasma, made of the newly formed hydrogen and helium nuclei, all swimming in a vast sea of free-roaming electrons. Though the fires of fusion had been extinguished, the universe was still glowing with a brilliant white-hot light, a light that was still trapped, bouncing endlessly from one free electron to another, like a firefly in a jar. This state of luminous captivity would persist for the next 380,000 years. It was a time of cosmic waiting. The universe had created its raw materials, but the conditions were not yet right for those materials to begin assembling into the complex structures we know. It was a universe filled with light, but a universe where nothing could yet be clearly seen. It was a time of cosmic patience, a long, quiet, and shimmering pause in the grand story of creation as the universe continued its slow, steady, and inexorable journey of expansion and cooling, preparing for the day when it would finally become clear. Following the fiery creative crescendo of the first few minutes, the universe settled into a long, quiet, and profoundly dark period of its history. This vast and tranquil era, known to astronomers as the Cosmic Dark Ages, lasted for hundreds of millions of years, a span of time far longer than humanity has existed. Though the cosmos was filled with all the matter that would ever be, and though it was bathed in the fading, stretching glow of the Big Bang, there were no stars to pierce the immense darkness. There were no galaxies to swirl in luminous spirals against the blackness. There was only a vast, expanding, and featureless ocean of neutral hydrogen and helium gas, growing ever cooler and more diffuse as the fabric of space itself continued to stretch. Imagine a fog that fills everything, a silent, uniform expanse, where the only discernible motion is the slow, inexorable, and invisible pull of gravity patiently gathering the seeds of future light. This was the universe. In its long and quiet childhood, a time of profound and almost absolute stillness between the initial chaotic creation and the eventual dawn of the first starlight. It was a time of cosmic waiting, of patient gathering, as the universe slowly and secretly prepared for its next great act of creation. In this immense and pervasive darkness, the only light that existed was the leftover glow from the Big Bang itself, the sea of photons that would one day become the cosmic microwave background. But during the Dark Ages, this ancient light was no longer visible light. As the universe had continued to expand, the wavelengths of these primordial photons had been stretched dramatically, shifting them far beyond the visible spectrum, first into the infrared, and then further still. To any hypothetical eye existing in that time, the universe would have appeared utterly and completely black. Even this primordial glow, the final echo of creation's fire, was now an invisible presence. The universe was a realm of true, unadulterated darkness, a place where the very concept of sight would have had no meaning at all. It was a world shaped not by light, but by more subtle forces, by temperature, by density, and by the silent, invisible whispers of gravity. In the profound and unbroken silence of this long era, the first seeds of all future cosmic structures were slowly, quietly, and patiently beginning to sprout in the gloom. The silent, unseen architect of this entire era was dark matter. This mysterious, invisible substance, which makes up the vast majority of all matter in the universe, had already begun to clump together under its own gravity, forming a vast and intricate cosmic web long before this. It was a completely invisible scaffolding, a hidden architecture of massive filaments and dense halos that stretched across the entire cosmos. While the ordinary matter, the newly formed hydrogen and helium gas, was constantly pushed and pulled by the pressure of the photons around it, dark matter felt only the gentle, persistent, and unwavering tug of its own gravity. It was the first to collapse into structures, creating the deep gravitational wells that would become the cradles for everything we can see. The neutral, ordinary gases that filled the universe during the Dark Ages now began its long, slow descent, drifting gently toward these unseen concentrations of dark matter, drawn by their immense and inescapable gravitational pull. It was a slow and patient rain of matter, a process that took hundreds of millions of years to unfold. The primordial gas flowed along the great invisible filaments of the cosmic web, like rivers flowing into a series of vast, unseen lakes, and it began to pool and collect at the very center of these dark matter halos. It was here, in the dense, dark, and cold heart of these invisible structures, that the first stars would eventually be born. The universe was building its foundations in secret, shaping the large-scale structure of the cosmos long before the first candle was ever lit. These vast, dark clouds of primordial gas were the true nurseries of the first stars. As more and more ordinary matter collected in the dense central knots of the dark matter web, the force of gravity began to take over with increasing strength. Pockets of gas within these clouds grew denser and denser, pulling in ever more material from their surroundings in a slow, gravitational cascade. The pressure and temperature at the very core of these collapsing clouds began to rise steadily, a slow burn of compression. It was a process that took millions upon millions of years. A slow, patient, gravitational squeezing that was occurring in countless locations across the vast, dark, and silent cosmos. The universe was on the verge of a great and magnificent awakening. The long, deep night of the cosmic dark ages was finally slowly drawing to a close. The conditions were becoming just right for the first nuclear fires to be lit, for the first brilliant points of light to shine out and courageously pierce the primordial unbroken darkness. The cosmic dark ages represent a period of profound and beautiful tranquility in the universe's long and tumultuous history. It was a time of unparalleled simplicity and silence, a long meditative pause after the chaotic heat of the very beginning. Contemplating this unique era can bring a sense of deep and resonant peace. It is a reminder that not all of cosmic history is filled with violent explosions and dazzling brilliant light. There are also essential times of quiet, patient, and unseen growth, times of preparation. As you settle into your own quiet darkness, preparing for the restorative journey of sleep, you can imagine yourself drifting weightlessly through this ancient starless cosmos. It is a place of perfect and profound stillness, where the only sound is the silent hum of gravity pulling matter together, and the only light is the distant promise of a dawn that is yet to come. It is a place where you can let go of the noise and the complexities of the day and simply be just as the universe was in its long, peaceful, and restorative night. And in that imagined stillness, you can find a perfect mirror for your own journey into rest. The Dark Ages were not an end, but a necessary and beautiful transition, a time for the universe to gather its strength and prepare for the next luminous chapter. In the very same way, sleep is not an absence of activity, but a time of quiet restoration, of gathering your own energy for the day to come. You are an intrinsic part of this grand cosmic rhythm of activity and rest, of brilliant light and profound darkness. And as you close your eyes, you are joining the universe in its most ancient and peaceful state, a state of quiet, dreamlike potential, waiting patiently for the gentle light of morning. For hundreds of thousands of years, the universe remained a hot, dense, and luminous, but utterly opaque fog. A brilliant light filled all of space, but this light was trapped endlessly, scattering off a sea of free-flying electrons, unable to travel more than a short distance before being deflected. It was a world without shadows, a world without sight. But as the cosmos continued its slow and steady expansion, it also continued to cool, approaching a critical and transformative threshold. When the universe was approximately 380,000 years old, the temperature dropped to a point about 3,000 degrees Kelvin, where it was no longer hot enough to keep atoms apart. For the very first time in cosmic history, the negatively charged electrons were captured by the positively charged hydrogen and helium nuclei, forming the first stable electrically neutral atoms. This monumental event is known to science as recombination. It was a moment of profound and universal transformation, a cosmic phase change on the grandest possible scale, akin to a vast cloud of steam suddenly condensing into droplets of clear water. The universe, which for eons had been a chaotic, energetic plasma, at last became a calm, stable, and electrically neutral gas. And with the capture of those free electrons, the primordial fog that had filled all of space suddenly and miraculously cleared. The countless photons of light, which had been trapped in an endless, frantic pinball game for nearly 400,000 years, were now in an instant set free. There was nothing left to scatter them. Their paths were now clear. The universe became transparent for the very first time. Imagine being deep inside a dense, impenetrable cloud, unable to see more than a few feet in front of you, and then, in a single, silent moment, the cloud completely vanishes, revealing the entire vast landscape for the very first time in a burst of perfect clarity. This was what happened to the entire universe. In that singular moment, a brilliant flash of light was released in all directions, a final, fading, and beautiful echo of the Big Bang's initial searing fire. This was the birth of the first true, unobstructed light of the cosmos, a light that would now begin its long and lonely journey across the expanding space and unfolding time for the next 13.8 billion years, a journey that would end in our telescopes and in our understanding. This ancient primordial light is what we now detect today as the cosmic microwave background, or the CMB. It is the oldest light in the universe, a perfect and precious fossil from a time before the first stars had even begun to form. The photons that were released during the moment of recombination have been traveling through space ever since. And as the universe has expanded over these billions of years, their wavelengths have been stretched out, shifting them from the spectrum of brilliant, visible, orange-white light into the cool, faint, and invisible microwaves that our radio telescopes can observe today. This CMB radiation fills all of space completely and uniformly. No matter where you point a sensitive radio telescope in the sky, you will find this gentle, persistent residual glow. It is a silent, pervasive whisper from the very dawn of time, a universal baby picture of the cosmos when it was just an infant, a perfect snapshot of the moment it took its first clear look at itself. This ancient picture, however, is not perfectly uniform. When we map it with incredible precision, we find that it is dappled with tiny, almost imperceptible variations in temperature. These faint and delicate ripples, with temperatures differing by only 1 part in 100,000, are extraordinarily important. They are the direct, fossilized imprints of the tiny quantum fluctuations that were stretched to cosmic size during the period of inflation, moments after the Big Bang. These minuscule temperature differences correspond to equally slight variations in the density of matter in the early universe. The slightly hotter, denser regions were the places where gravity would have a tiny, almost insignificant extra advantage. But over the course of hundreds of millions of years, that tiny advantage would be enough. These regions would slowly and patiently pull in more and more gas, becoming the gravitational seeds around which all the magnificent structures we see in the universe today would eventually form. Every galaxy, every star cluster, every great filament of the cosmic web can trace its distant origin back to one of these faint, ancient, and almost invisible ripples in the very first light of the universe. Studying the cosmic microwave microwave background in minute detail has completely revolutionized our understanding of the cosmos. By analyzing the intricate patterns of these tiny fluctuations, their size, their distribution, and their polarization, scientists can learn about the age, the composition, and the geometry of the universe with an accuracy that was once thought impossible. The CMB has confirmed our theories of the Big Bang with stunning precision, provided the strongest evidence we have for the existence of dark matter and the mysterious force of dark energy, and it has given us a direct glimpse into the physical conditions of the universe in its very first formative moments. The CMB is far more than just old light. It is a treasure map of creation, a Rosetta Stone that allows us to translate the faint, cool glow of the distant past into a detailed, rich, and beautiful story of our own cosmic origins. It is the most powerful and profound tool we have for understanding where we came from and how the universe itself came to be. And as you lie here in the quiet, peaceful darkness, you are bathed in this ancient, gentle light. The microwaves of the CMB are passing through you right now, just as they are passing through everything and everyone in the universe. They are a constant, gentle, and physical reminder of your deep connection to the cosmos, a tangible link to a time when the universe was young, simple, and filled with a brilliant, hopeful promise. You are part of a universe that is filled with memory, a universe that carries the echoes of its own birth in every corner of space. And in the stillness of the night, you can feel that profound connection, that sense of being part of something vast, ancient, and unspeakably beautiful. Let that feeling of deep connection be a source of profound peace. A gentle cosmic lullaby from the very heart of creation as you drift deeper and deeper into a state of serene, untroubled, and restful sleep. The ancient, gentle light of the cosmic microwave background carries more than just the memory of the universe's first moment of transparency. It carries within its subtle patterns the very blueprints of all future creation. When astronomers use their most sensitive instruments to map this light from the dawn of time, they find that it is not a perfectly smooth, uniform glow. Instead, it is mottled with tiny, almost imperceptible, hot and cold spots, delicate ripples in the temperature that vary by just a fraction of a degree from one patch of the sky to another. These subtle variations are known as the anisotropies of the CMB, and they are the direct fossilized imprints of the quantum fluctuations that were born in the universe's first instant and stretched to cosmic size during the period of inflation. These were the very first seeds of structure in the cosmos, the starting points for everything that would ever be built. The slightly warmer, and therefore slightly denser regions were the places where the force of gravity would have a tiny, almost insignificant extra advantage. But over the vast timescales of cosmic history, even the smallest advantage is enough. Over hundreds of millions of years, these regions would slowly and patiently pull in more and more of the surrounding primordial gas, becoming the deep gravitational wells where the first stars and the first galaxies would eventually ignite and form. The slightly cooler and therefore slightly less dense regions would in turn give up their matter to their denser neighbors, eventually becoming the great empty cosmic voids that separate the vast chains of galaxies today. In a very real and beautiful sense, the grand and intricate architecture of the entire universe, the sprawling superclusters, the delicate filaments, and the vast, silent, empty spaces was sketched out in these faint, ancient, and almost invisible ripples in the very first light of the universe. And within these beautiful, dappled patterns, scientists have discovered something even more profound. the clear and unmistakable echo of ancient sound waves. In the hot, dense plasma of the early universe, before recombination, the cosmos was a place where sound could travel and travel on a magnificent scale. The constant battle between the outward pressure of the brilliant light and the inward pull of gravity created vast and powerful oscillations in the primordial soup. These were ripples of compression and rarefaction areas where matter and energy were slightly more or less dense, that were in their very essence sound waves of a truly cosmic scale. These waves, with wavelengths spanning hundreds of thousands of light years, sloshed back and forth through the infant universe. Their intricate and harmonic patterns were then frozen in place at the precise moment the universe became transparent and the light was set free. Today, we can still see their distinct signature in the cosmic microwave background, a characteristic and preferred pattern in the size of the hot and cold spots. These patterns are known as baryon acoustic oscillations, and they act like a standard ruler that has been imprinted on the fabric of the cosmos. By measuring the apparent size of these ancient ripples in the sky, scientists can measure the expansion history of the universe with incredible and beautiful precision. It is an almost poetic and deeply moving idea that the universe, in its infancy, was ringing and humming like a great cosmic bell, and that we can still hear the faint frozen and silent echoes of that primordial sound in the patterns of light from the very beginning of time. By studying the intricate geometry of these ancient ripples, cosmologists have also been able to determine the overall shape of our universe with astonishing accuracy. The angular size of the largest fluctuations in the CMB, as we see them today, tells us a story about how light has traveled through space over the past 13.8 billion years. And this in turn reveals the fundamental curvature of space-time on the largest possible scales. What the data from our most advanced telescopes tells us with a high degree of confidence is that the universe is astonishingly almost perfectly flat. This means that on a cosmic scale, the rules of ordinary Euclidean geometry that we learn in school still apply. Two parallel lines of light will remain parallel forever, never converging or diverging, and the angles of a vast cosmic triangle will always add up to exactly 180 degrees. This observed flatness implies that the universe possesses a critical density, a perfect and delicate balance between the total amount of matter and energy, pulling it together through gravity, and the expansive, mysterious force of dark energy pushing it apart. This delicate and perfect balance is a key prediction of the theory of inflation, and its stunning confirmation through the CMB is one of the great triumphs of modern cosmology. It means we live in a universe that is poised on a cosmic knife's edge, a universe whose fundamental geometry is simple, elegant, and infinitely vast. But amidst this beautiful, elegant, and well-understood pattern of ripples, there are quiet and subtle anomalies that continue to puzzle and intrigue scientists. One of the most famous and debated of these is the CMB cold spot. This is a particular region of the sky that is unusually large and unusually cold, significantly colder than the standard model of cosmology predicts should be possible as a simple random fluctuation. Its existence has led to a host of speculative and fascinating theories. Some scientists believe it may be the gravitational imprint of an enormous supervoid, a vast region of space, perhaps billions of light years across, that is almost entirely empty of galaxies and dark matter. The light from the CMB passing through such an empty region would lose a tiny bit of energy, making it appear cooler to us. Others have proposed more exotic and mind-bending explanations, suggesting that the cold spot could be the bruise left behind from a gentle collision between our own universe and another bubble universe in the distant primordial past. For now, the cold spot remains an open and tantalizing question. A quiet, unsettling whisper in the cosmic data that reminds us that for all we have learned and all we have understood, the universe may still hold deep and profound secrets that lie beyond our current comprehension. The polarization of this ancient light also tells a rich and detailed story. Light waves can oscillate in different directions, and the light from the CMB has a faint but measurable polarization, a preferred direction of oscillation. This polarization was created as the light scattered off of free electrons for the very last time, before being set free at the moment of recombination. The subtle and intricate patterns of this polarization encode a wealth of precious information. They can tell us about the exact conditions at the moment the universe became transparent, and they can even carry the faint, ghostly, and almost invisible signature of primordial gravitational waves, the ripples in space-time itself that may have been generated during the violent expansion of inflation. The search for these specific swirling polarization patterns known as B-modes is one of the great and ongoing quests of modern cosmology. If they are ever detected, they would be the smoking gun for inflation, direct and undeniable evidence of the universe's first most violent and most creative moment. It would give us a direct window into the physics of the universe at an energy scale far beyond anything we could ever hope to create on Earth. The CMB is not just a simple picture. It is a rich, multi-layered, and deeply informative message from our past written in temperature, in pattern, and in the delicate and beautiful orientation of light. As the universe finally became transparent and the first light began its long and silent journey across the cosmos, the slow, patient, and monumental work of building cosmic structures began in earnest. The primary engine of this grand construction was not the familiar matter of atoms and gas that we can see and touch, but something entirely unseen, something deeply mysterious, something that we now call dark matter. This invisible and elusive substance, which we can only detect through its subtle and persistent gravitational pull on the things we can see, had already been hard at work during the long cosmic dark ages. It had formed a vast and intricate cosmic web, an invisible scaffolding, a hidden architecture of massive filaments and dense spherical halos that stretched across the entire newly cleared cosmos. While ordinary matter, the hydrogen and helium gas, was constantly being pushed and pulled by the intense pressure of the photons around it, dark matter felt only the gentle, persistent, and unwavering tug of its own gravity. It was therefore the first to truly collapse into coherent structures, creating the deep and powerful gravitational wells that would become the sacred cradles for everything we can see in the universe today. The universe was being built from the inside out, with a vast invisible framework of dark matter, quietly and patiently guiding the placement and formation of every future star and every future galaxy. These very first structures to take shape in the universe were called dark matter halos. They were vast, roughly spherical clouds of this unseen, mysterious matter, with sizes ranging from much smaller than a single galaxy to far larger than the most massive superclusters we see today. They form the dense and heavy nodes of the great cosmic web, the critical intersections where the pull of gravity was at its absolute strongest. Now that the universe was transparent, the ordinary matter of the cosmos, the primordial hydrogen and helium gas that had been set free at the moment of recombination, began its long and gentle fall into these pre-existing halos, drawn by their immense and inescapable gravitational pull. It was a slow and patient rain of ordinary matter onto an invisible landscape, a process that took hundreds of millions of years to complete. The primordial gases flowed along the great invisible filaments of the cosmic web, like cosmic rivers, flowing into a series of vast unseen lakes, and it began to pool and collect at the very center of these massive dark matter halos. It was here, in the dense, dark, and cooling heart of these invisible structures, that the very first stars would finally be born, their light destined to illuminate a universe that had been shaped and prepared by a substance they could never reveal. Without the silent and patient work of dark matter, the universe as we know it simply would not exist. The tiny density fluctuations that we see imprinted on the cosmic microwave background were not nearly strong enough on their own to form galaxies in the time that has passed since the Big Bang. The gentle pull of gravity needed a significant boost, a crucial head start. Dark matter provided exactly that. Because it did not interact with light, it was completely free to begin the process of clumping together under its own gravity, long before ordinary matter could back when the universe was still an opaque, luminous fog. It created the deep and stable gravitational wells that gave ordinary matter a target to fall into a place to gather and concentrate. If our universe had been created with only the matter that we can see, the constant expansion of space would have likely overcome the weak gravitational pull of the gas clouds, leaving the cosmos a thin, featureless, and eternally dark soup of diffuse gas with no stars, no galaxies, and therefore no possibility of life. Dark matter is the quiet, unsung, and invisible hero of cosmic structure, the silent hand that sculpted the universe from the bottom up and ultimately made our own existence possible. The profound mystery of what dark matter actually is remains one of the greatest and most compelling challenges in all of modern science. We know with a high degree of certainty that it is there. We can map its gravitational effects with stunning precision, watching how it bends the light of distant galaxies and how it governs the rotation of our own. But we still do not know what it is made of. The leading theories from particle physics suggest that it could be a completely new type of stable, massive subatomic particle 1 that was forged in the heat of the Big Bang and does not interact with light or with ordinary matter except through the gentle force of gravity. These hypothetical particles have been given imaginative names like WIMPs, which stands for Weakly Interacting Massive Particles, or Axions, another ghostly candidate. All around the world, dedicated scientists are running incredibly sensitive experiments, often buried deep underground in old mine shafts to shield them from other forms of cosmic radiation. They are hoping to catch the faint, fleeting, and almost impossibly rare signal of a single dark matter particle colliding with a single ordinary atom in their detectors. So far, this exhaustive and patient search has come up empty. Dark matter remains a persistent ghost in the great cosmic machine, its presence absolutely essential for the universe to work, but its fundamental nature completely and utterly unknown to us. This invisible and mysterious majority shapes not only the grandest cosmic structures, but also the individual galaxies themselves, including our own beautiful home, the Milky Way. The stars in the outer regions of our galaxy are moving far too fast. Their orbital speeds are so great that they should easily escape the gravitational pull of all the visible stars, gas and dust. They should be flung off into the cold, empty darkness of intergalactic space. The reason they are not is the immense unseen and spherical halo of dark matter that surrounds our entire galaxy, holding it together with its gentle but powerful gravitational embrace. Dark matter dictates how galaxies rotate, how they cluster together to form the cosmic web, and how they grow and evolve over the billions of years of cosmic time. It is the dark, silent, and dominant partner in the grand and beautiful dance of cosmic evolution. A partner that outweighs all the visible stars and luminous gas by a staggering factor of 5 to 1. The universe we see is far, far more than what meets the eye. It is a place of vast hidden substance, of quiet invisible forces that shape reality in ways we are only just beginning to comprehend and appreciate. As you lie here on the peaceful edge of sleep, you can let your mind imagine this invisible world that is all around you. The room you are in, the planet you are on, the entire solar system, is currently moving at hundreds of thousands of miles per hour through a vast, diffuse, and invisible halo of dark matter. Particles of this mysterious substance are streaming silently and harmlessly through you right now, as gentle and as unnoticed as the faint light from the most distant stars. They do not touch you. They do not affect you, but they are a fundamental part of your reality. They are the invisible cosmic river in which your home galaxy floats. There is a deep and profound sense of peace to be found in this idea that the universe is held together not by violence and fire, but by a quiet, persistent, and unseen presence. It is a reminder that the most important and foundational things are often the ones we cannot see. Let that thought be a gentle, comforting anchor, holding you in a state of calm and boundless wonder as you drift softly and peacefully into the deep and beautiful mystery of sleep. As the universe's long, quiet, and starless night began to finally draw to a close, a new and brilliant light was preparing to dawn across the cosmos. In the dense, cool, and dark hearts of the very first and most massive dark matter halos, the patient, relentless work of gravity had succeeded in gathering vast and pristine clouds of hydrogen and helium gas. For millions of years, these primordial clouds had been slowly collapsing inward, growing ever denser and hotter at their turbulent cores. Eventually, after a long and silent period of gestation, the pressure and temperature at the very center of the most massive of these collapsing clouds reached a critical and magical point, a staggering 10 million degrees. At that precise temperature, a new and wondrous kind of fire was lit in the universe. The process of nuclear fusion began. The nuclei of hydrogen atoms, the simplest and most abundant material in the all of cosmos, started to be crushed together with such incredible force that they fused to form helium, releasing a tremendous and beautiful amount of energy in the process. This was the birth of the very first stars, and with their magnificent ignition, the long and silent night of the cosmic dark ages finally came to a spectacular and luminous end. The universe at last had created its own light. These very first stars, known to astronomers by the poetic name of Population 3, stars were utterly unlike anything that exists in the universe today. They were forged from the pure, pristine, and untouched gas left over from the Big Bang, a simple and elegant recipe of almost pure hydrogen and helium with virtually no heavier elements to speak of. Because their composition lacked these metals, as astronomers refer to all elements heavier than helium, they were able to grow to truly colossal and magnificent sizes unhindered by the cooling mechanisms that limit the size of modern stars. The first stars may have been hundreds, or in some cases even thousands of times more massive than our own familiar sun. As a result, they would have been incredibly searingly hot, shining with a brilliant piercing blue-white light, a light that was perhaps 1,000,000 times more luminous than our sun. They were true cosmic giants, solitary, majestic, and magnificent, lighting up the primordial, unbroken darkness with a brilliance and a purity that the universe had never seen before and would never see again. But these brilliant and spectacular lives were destined to be tragically and beautifully brief. The more massive a star is, the more furiously and quickly it burns through its precious nuclear fuel. These first stellar giants lived for only a few million years, a mere and fleeting blink of an eye, on the grand canvas of cosmic timescales. They blazed with an almost unimaginable intensity, flooding their surroundings with a torrent of powerful and transformative ultraviolet radiation. And then they died in the most spectacular and meaningful way imaginable. They exploded as the universe's very first supernovae, cataclysmic and universe-altering events that were for a brief, shining moment brighter than the entire nascent galaxies they inhabited. These first explosions were not just endings, they were also profound and necessary acts of creation. In their fiery and brilliant death throes, these first stars forged the very first heavy elements in the universe: the carbon, the oxygen, the nitrogen, and the iron that had been impossible to create in the fleeting moments of the Big Bang. These newly forged and precious heavy elements were then blasted out into the vastness of space by the shock waves of the supernova, enriching the surrounding primordial gas clouds with new and complex ingredients. This was a pivotal and transformative moment in the history of the cosmos. The universe was no longer a simple and monotonous place made of only two elements. It was finally slowly becoming chemically complex. These heavy elements would then be incorporated into the next generation of stars that form from these enriched clouds, and those stars in turn would create even more heavy elements in their cores in a continuous and beautiful cycle of stellar birth, life, and death that has continued ever since, right up to the present day. The carbon in your body, the oxygen you are breathing in this very moment, the iron flowing in your blood, all of it was created in the heart of a star that lived and died long ago. And the very first of those life-giving atoms were forged in the spectacular and beautiful deaths of these first magnificent and short-lived population 3 stars. We are all, in the most literal and profound sense, made of stardust, the ancient light, and the recycled matter of stars that lived and died long before our own sun was even a faint and distant glimmer in a cloud of cosmic dust. The birth of these first stars was not a single, simultaneous event that happened everywhere at once. It was a gradual and beautiful awakening that took place in isolated pockets across the vast, dark, and silent universe, wherever the conditions were just right. The cosmos did not simply turn on like a light switch. It began instead to twinkle. Here and there, in the heart of a distant dark matter halo, a new star would ignite a solitary and courageous beacon in the immense and overwhelming darkness. Then another would appear, and then another. These first precious points of light began to push back the primordial gloom, their powerful radiation carving out expanding bubbles of ionized, transparent gas in the surrounding neutral fog. The universe was slowly waking up from its long slumber, gently, and one star at a time. The cosmic dawn had finally and irrevocably begun, and the universe would never be dark again. As you lie here, letting the comforting stillness of the night settle over you, you can let your mind imagine that first ancient and silent dawn. Picture a universe of perfect and unbroken darkness, a silence that has lasted for hundreds of millions of years, and then a single brilliant point of light appears pure and magnificent. Then another appears, and another after that. It is the quiet, steady, and inevitable arrival of light into a world that has known only darkness. There is a deep and comforting rhythm to this beautiful story, a sense of a natural and graceful unfolding. The universe was not in a hurry. It took its time, waiting patiently for the perfect moment to bring forth the light. And in that patient, graceful, and beautiful emergence, there is a profound lesson of peace. Let your own mind follow that gentle and steady rhythm, letting go of the urgency and the noise of the day and allowing yourself to drift peacefully into the quiet starlit darkness of your own inner cosmos, just as the universe did in its long and hopeful dawn. The very first stars, those brilliant and solitary giants, were not destined to shine alone in the primordial darkness for long. Gravity, the patient and relentless sculptor of the entire cosmos, continued its slow and steady work, pulling these newborn stellar titans and the vast clouds of gas that surrounded them closer and closer together. The massive dark matter halos that had served as their initial cradles now became the gravitational centers of larger and more complex gatherings. These first stars, along with the swirling pristine gas that had not yet been consumed, began to merge and cluster under their mutual gravitational attraction, forming the very first recognizable galaxies in the universe. These were not the grand, majestic, and well-ordered spirals like our own Milky Way that we see in the sky today. They were small, chaotic, intensely active, and beautifully messy protogalaxies. They were little more than dense and vibrant collections of a few million stars. But they were the crucial and essential seeds from which all the great cosmic cities of light that now populate the universe would one day grow. Imagine small, brilliant, and energetic swarms of light, like clusters of fireflies in the vast, dark, and endless forest of the early universe, slowly and gracefully drifting toward one another, drawn by the invisible and inescapable force of gravity. These early nascent galaxies were violent, turbulent, and breathtakingly beautiful places. They were undergoing intense and furious bursts of star formation, a process far more rapid and chaotic than what we typically observe in the more settled and mature galaxies of our own cosmic neighborhood. The abundant primordial gas within them was being rapidly and efficiently converted into new generations of stars, which then lived out their own short, brilliant lives and exploded as powerful supernovae by flooding the young galaxies with a constant supply of transformative energy and enriching them with the first heavy elements. These frequent and powerful explosions in turn sent shockwaves through the surrounding gas, triggering new and even more intense waves of star formation creating a self-sustaining and spectacular cycle of cosmic fireworks. Furthermore, these proto-galaxies were constantly colliding and merging with one another. The early universe was a much smaller and denser place than it is today. And these fundamental galactic building blocks were constantly interacting, their delicate and powerful gravitational dance shaping them into larger, more massive, and more complex structures over the course of billions of years. It was a time of grand cosmic construction, a chaotic and beautiful era of assembly as the universe began to build its first great and enduring monuments of light and matter. For many decades, this formative era of the first galaxies was a realm of pure theory and imagination. A crucial chapter in the cosmic story that was frustratingly beyond the reach of our most powerful telescopes. But with the recent advent of the James Webb Space Telescope, we are now for the very first time in human history able to peer directly into this ancient and luminous dawn. The JWST, with its incredible and unprecedented sensitivity to the faint infrared light from the most distant objects, can capture the faint red-shifted glow of these very first galaxies' light that has been traveling toward us across the expanding universe for over 13 billion years. And what this remarkable telescope is revealing is a universe that was surprisingly and beautifully advanced, even in its earliest infancy. The telescope has found galaxies that are more massive, more structured, and more chemically mature than our previous models had ever predicted. It has seen the clear chemical signatures of complex molecules and interstellar dust, and even the faint ghostly hints of spiral arms and galactic bars and galaxies that existed when the universe was just a few 100 million years old, a mere fraction of its current age. These groundbreaking and astonishing discoveries are forcing scientists to fundamentally rethink their understanding of how quickly galaxies can form, assemble, and evolve. It seems the universe was not just building its structures slowly and steadily. It was building with a surprising and remarkable speed and efficiency. The quiet, patient, and relentless work of gravity may have been even more effective than we had ever imagined, assembling the first grand and complex structures in what amounts to a cosmic blink of an eye. The images that the JWST sends back to us are like precious postcards from a long-forgotten time, each one a faint, fuzzy, and beautiful smudge of reddish light that represents an entire island of stars, a place where the cosmic story was just beginning to unfold in all its glory. They are our first clear windows into a younger, wilder, and more vibrant universe. A place that is at once deeply alien and yet strangely and comfortingly familiar. A place where the same laws of physics that govern our world were just beginning to paint their first masterpieces on the canvas of the cosmos. The light from these very first galaxies is the most ancient starlight that we will ever be able to see. It is a direct and physical message from a time when the universe was just beginning to find its lasting form, a time when the profound and pervasive darkness of the cosmic dark ages was finally and irrevocably giving way to a new era of light. To look at these breathtaking images is to look back across almost the entire unimaginable expanse of cosmic history, to see the universe not as it is today, but as it once was, in all its youthful and chaotic beauty. It is a profoundly humbling and deeply moving experience, a powerful reminder of the immense age and incomprehensible scale of the cosmos and of our own small, fragile, but incredibly precious place within it. We are the fortunate beneficiaries of this ancient and beautiful light, the living inheritors of a universe that has been patiently building, evolving, and growing more complex for billions upon billions of years. As you settle deeper and deeper into a state of rest, you can let your mind drift back to this incredible time of cosmic dawn. Imagine the quiet and total darkness, and then the first faint and beautiful smudges of light beginning to appear in the void, the first galaxies slowly taking shape like crystals forming in a solution. There is a profound sense of hope and boundless promise in this beautiful image, a feeling of emergence, of becoming, and of light conquering the darkness. The universe was not static. It was vibrantly alive with the grand and beautiful process of creation. And you, in your very essence, are a part of that ongoing creative process. Your own consciousness, your own remarkable ability to wonder, to imagine, and to dream is a direct product of this long, patient, and beautiful cosmic journey. Let the gentle and ancient light of those very first galaxies be a beacon for your mind, guiding you softly and peacefully toward a state of deep, untroubled, and restorative sleep, a state where you can rest securely in the knowledge that you are a part of a story that is as vast, as beautiful, and as full of light as the cosmos itself. As the first brilliant stars and chaotic young galaxies ignited across the primordial cosmos, they began to fundamentally and permanently transform the very nature of the universe around them. For hundreds of millions of years, the cosmos had been filled with a vast neutral and opaque fog of hydrogen gas, the same primordial fog that had defined the long and silent night of the cosmic dark ages. This pervasive gas was completely opaque to the most energetic forms of light, particularly the powerful ultraviolet radiation that streamed from these new celestial objects. But the first stars were incredibly hot and unimaginably massive, and as a result, they poured out a relentless and powerful torrent of this very same ultraviolet light. This intense radiation began to do something remarkable and transformative. On a cosmic scale, it started to reionize the universe. The energetic photons produced by these first stars were powerful enough to strip the single electrons from the neutral hydrogen atoms that filled all of space, breaking them apart and turning the cool, neutral gas back into a hot, transparent plasma. It was the universe's second great phase transition, a final and irreversible clearing of the primordial mist that had shrouded the cosmos since its infancy. This monumental process, known to astronomers as the era of Ryanization, did not happen all at once in a single universe-spanning flash. It was a gradual and beautiful process that began in isolated bubbles. Around each of the first stars and the first small galaxies, expanding bubbles of ionized transparent space began to form like clearings in a dense and endless fog. Inside these newly formed bubbles, the light from the stars could travel freely, illuminating the gas within. But outside these bubbles, the vast majority of the universe was still a dark, cold, and opaque fog. As more and more stars and galaxies formed over the course of millions of years, these individual bubbles of clarity grew larger and larger, eventually beginning to overlap and merge with one another. It was like a network of clearings appearing and expanding in a dense cosmic forest, growing and joining together until the entire forest was gone, replaced by an open and sunlit plain. This entire process took hundreds of millions of years to complete, a slow, patient, and inexorable transformation of the entire cosmos, driven by the collective light of its first luminous children. The universe was slowly and gracefully lifting its own veil, allowing the brilliant light of its newborn galaxies to finally shine out across the vastness of space and time. This was also a dramatic and at times violent period for the young universe. The intense and relentless radiation from these first stars and galaxies heated the surrounding intergalactic gas to thousands of degrees. This heating process had a profound effect on the formation of all subsequent galaxies. It evaporated smaller clouds of gas, preventing them from collapsing to form new small galaxies. This effectively raised the minimum mass required for a galaxy to form, meaning that only the largest and most massive dark matter halos could continue to accrete gas and build new generations of stars. It was a form of cosmic feedback, a self-regulating process on a grand scale. The formation of the very first structures fundamentally changed the conditions of the universe, which in turn affected how all subsequent structures would be allowed to form. Reionization was not just a simple clearing of the cosmic fog. It was a fundamental and permanent reshaping of the entire cosmic ecosystem. It marked the definitive end of the universe's simple, cool, and neutral state, and the true beginning of the complex, hot ionized, and beautifully transparent cosmos that we inhabit today. The light from this transformative era is incredibly faint and difficult to observe directly from our vantage point billions of years in the future. We are effectively looking for the faint and distant shadow of that last remaining neutral hydrogen gas at the very edge of the observable universe. But astronomers are using some of the most powerful radio telescopes on Earth to try and capture the faint sound of this great transition. They are listening for the faint specific radio waves that are emitted by the spinning electrons in that ancient primordial hydrogen gas before it was completely ionized. By carefully mapping this faint red-shifted signal across the sky, they hope to create a three-dimensional picture of the reionization process itself, to watch in a sense as those first bubbles of transparency formed, grew, and merged together. It would be like watching the cosmic weather report from 13 billion years ago, a detailed map of the final great storm that forever cleared the primordial skies and allowed the universe to become the sea of light we know. The era of reionization is a powerful and beautiful reminder that the universe is not a static and unchanging stage, but a dynamic and constantly evolving entity. The very conditions that we take for granted today, the clear, dark, and transparent space that lies between the stars and galaxies, had to be actively created. They were the hard-won result of a long and dramatic process, a cosmic battle between the forces of light and darkness that was waged on the grandest possible scale across the entire universe for hundreds of millions of years. In the end, the light won, and because it won, we are able to look out into the universe and see the distant, beautiful galaxies to piece together the intricate and wonderful story of our own cosmic origins. We live in the clear, transparent, and peaceful aftermath of this ancient and profound transformation. Every single time you look up at the star-filled night sky, you are looking through a window that was painstakingly opened, bubble by bubble, by the brilliant and courageous light of the very first stars. Let this beautiful idea of clearing of a fog hole, lifting to reveal a world of perfect clarity, bring a sense of profound peace to your mind. Imagine a thick and heavy fog, perhaps representing a feeling of uncertainty or confusion in your own life. And then imagine it slowly, gently, and peacefully beginning to lift. Imagine small, warm bubbles of clarity appearing, growing, and merging until everything is clear, calm, and bright. This is the true story of our universe, and it can also be the story of your own mind as you drift peacefully towards sleep. Let the worries and the complexities of the day be like that ancient primordial fog, and let the gentle light of your own quiet awareness, the soft and steady rhythm of your own breath, be the force that clears them all away, leaving behind only a state of pure, peaceful, and beautifully transparent stillness. Rest now in that clarity, in that gentle, open, and luminous space that the universe itself worked so long and so hard to create for you. Even as the early universe was being triumphantly illuminated by the light of its first stars, another far more mysterious and silent class of cosmic giants was beginning to take shape in the darkness. Deep in the dense, gas-rich hearts of the very first and most massive galaxies, supermassive black holes began to grow with an astonishing and puzzling speed. Today, we know that nearly every large galaxy, including our own beautiful Milky Way, hosts a monstrous and unseen black hole at its very center, a gravitational behemoth weighing millions, or in some cases, even billions of times the mass of our sun. But the profound mystery that continues to challenge astronomers is how these gravitational giants managed to grow so massive so very quickly in the early universe. Our most advanced observations of the distant cosmos have revealed the existence of quasars incredibly luminous and energetic galactic cores that are powered by these rapidly feeding black holes, which were already fully formed and shining with incredible intensity when the universe was less than 1 billion years old. This presents a deep and fascinating puzzle. According to our standard models of black hole growth, there simply does not seem to have been enough time for a black hole starting from the collapse of a single star to grow to such a colossal size through the slow, steady, and gradual process of swallowing individual stars and clouds of gas. The universe, it seems, had a secret and much faster way of building its monsters. This profound timing problem has led scientists to explore a range of more exotic and dramatic theories for the origin of these cosmic giants. One of the leading ideas is that the very first population 3 stars, which were themselves hundreds of times more massive than our sun, did not always explode as brilliant supernovae. Instead, the most massive among them may have collapsed directly and completely into black holes at the end of their short lives. These seed black holes, born from the death of a single colossal star, would have been much larger to begin with than the black holes formed from the collapse of smaller stars today, giving them a significant and crucial head start in their race to grow. These seeds would have been born in the most ideal of locations, the dense gas-rich and chaotic centers of the very first proto-galaxies, a perfect and target-rich environment to begin feeding voraciously and growing at an exponential rate. In this beautiful and compelling scenario, the first brilliant lights of the universe and the first deep shadows of the universe were born almost side by side, locked in a cosmic dance of creation and consumption from the very beginning of galactic history. Another even more dramatic and breathtaking theory is the concept of direct collapse black holes. Scientists have calculated that in the early universe, under certain rare and specific conditions, a vast and pristine cloud of primordial gas, perhaps weighing as much as 1 million times the mass of our sun, could have collapsed under its own immense gravity without first fragmenting to form a myriad of individual stars. The entire colossal cloud would have fallen inward in a single catastrophic and silent event, directly forming a truly massive black hole in one swift and decisive move. This remarkable process would completely bypass the slow and gradual process of stellar evolution, creating an instant cosmic giant without the need for a stellar precursor. These direct collapse events would have been incredibly rare, occurring only in places where the gas was exceptionally pure and unable to cool efficiently. But they may have been responsible for seeding the very first and most massive supermassive black holes that we now see at the center of the largest and oldest galaxies in the universe today. It is a breathtaking and almost unimaginable idea. A vast, dark, and starless cloud of primordial gas in a single silent and final collapse, giving birth to one of the most powerful and influential objects in the entire cosmos. And there is yet another, even more ancient possibility, one that reaches even further back in time to the very first second of the universe's existence. Some scientists have proposed that primordial black holes may have formed in the first fiery and chaotic moments after the Big Bang itself. In the incredibly dense and turbulent conditions of the early universe, tiny random fluctuations in density could have been so extreme in some places that they collapsed directly and immediately into black holes without ever having been stars or even gas clouds. These primordial black holes, forged in the very crucible of creation, could have come in a wide and fascinating range of sizes, from smaller than a single atom to many thousands of times the mass of our sun. If these ancient and unseen objects truly exist, they could have served as the original seeds around which the first dark matter halos and the first galaxies themselves formed their powerful and pre-existing gravity, providing the perfect anchor for all future cosmic structure. In this intriguing view, black holes are not just the dramatic and final endpoint of stellar evolution. They are a fundamental and intrinsic part of the universe's initial conditions woven into the very fabric of space-time from the very first explosive moment of its existence. The undeniable existence of these ancient, unexpectedly massive black holes continues to challenge our most fundamental understanding of cosmic evolution and serves as a powerful and humbling reminder of how much we still have to learn about the universe's earliest and most formative years. They are the quiet, dark, and unseen giants that have presided over the long and beautiful history of galaxies, their immense and inescapable gravity shaping the graceful orbits of the countless stars that swirl around them, their powerful and energetic jets of plasma regulating the birth of new stars across entire galactic ecosystems. They are at once creators and destroyers, the silent and powerful engines of cosmic feedback that have played a central and undeniable role in shaping the very universe that we see around us today. They are the silent, invisible, and ever-present heart of the great cosmic cities of light. As you lie here, resting peacefully on the quiet threshold of sleep, you can let your mind rest in the presence of this great and profound mystery. Imagine these silent, ancient, and powerful giants hidden deep in the luminous hearts of the most distant galaxies. They are not objects of fear, but of boundless wonder. They represent the awesome and beautiful power of gravity, the fundamental force that both builds and consumes the very same force that holds your own body gently and securely to the earth as you rest. There is a sense of deep, unshakable, and profound stability in the presence of a black hole, a point of perfect and eternal stillness in a constantly swirling and evolving cosmos. Let that feeling of quiet, powerful, and serene stillness fill your own being. Let it be a source of deep calm and security, a gentle reminder that even in the face of the greatest and most profound mysteries, there is a kind of peace to be found, a peace that comes from the simple act of letting go, from surrendering to the gentle, irresistible, and comforting pull of sleep. Beyond the ancient light of the first stars and the profound, silent mystery of the first black holes, there are other, even fainter and more ghostly echoes from the very beginning of time. These are the subtle, almost imperceptible messengers that are still traveling toward us today across the vast expanding expanse of the cosmos, carrying with them the deepest secrets of creation. One of the most sought after and precious of these is the faint rhythmic whisper of primordial gravitational waves. These are not waves of light or matter, but delicate, trembling ripples in the very fabric of space-time itself. The prevailing theory of inflation, that moment of exponential expansion in the universe's first instant, predicts that this violent and rapid stretching would have shaken the entire cosmos, creating a pervasive background of these waves that should still be permeating all of space today. These ancient waves would now be incredibly faint, their gentle stretching and squeezing of the space around us far, far smaller than the width of a single atom. But if we could ever develop the technology to detect them, they would be a direct and unfiltered window into the physics of the universe's very first fraction of a second, a time far earlier and far more energetic than anything the light of the cosmic microwave background can ever reveal to us. All around the world, dedicated scientists are building incredibly sensitive and ambitious experiments, both on the surface of the Earth and planned for the quiet vacuum of space, to try and listen for this ancient cosmic hum. They are searching for a very specific faint and swirling pattern in the polarization of the cosmic microwave background, a unique and unmistakable signature that could only have been left behind by the passing of these primordial gravitational waves. The patient and painstaking search for these signals is one of the great and noble quests of modern physics. To finally find these waves would be akin to hearing the true resonant echo of the Big Bang itself, to capture the final, fading resonance of the universe's first most violent and most creative moment. It would be a discovery that would fundamentally transform our understanding of our own cosmic origins and would stunningly confirm one of the most audacious and beautiful ideas in the entire history of science. For now, the universe keeps its deepest secret, but we are listening with ever-increasing sensitivity, patiently and quietly listening for the faintest and most ancient sound from the very beginning of all time. Another ghostly and elusive messenger from this incredibly early era is the cosmic neutrino background. We have already spoken of the vast sea of relic neutrinos that decoupled from the hot, dense primordial soup in the universe's very first second of existence. These tiny, almost massless particles, trillions of which are passing silently and harmlessly through you and through the entire planet at this very moment, represent the oldest possible snapshot of the universe that we could ever hope to obtain. They carry a memory from a time that is even older than the light of the cosmic microwave background. But because these ghostly particles interact so incredibly weakly with ordinary matter, detecting this faint and ancient background directly is a task of almost unimaginable and heartbreaking difficulty. The primordial neutrinos from the Big Bang have been traveling for so long, and the universe has expanded so much in that time that their energy is now incredibly, almost immeasurably low. They are moving so slowly that they are almost impossible to distinguish from the constant low-level background noise of other more modern particles. And yet their subtle and collective presence has helped to shape the universe. Their combined gravity, though individually tiny, has had a subtle but measurable effect on the formation of the large-scale structures of the cosmos and on the intricate and beautiful patterns that we see in the cosmic microwave background. By carefully and precisely studying these subtle gravitational effects, scientists can infer the properties of these ancient unseen particles, and thereby confirm their existence even without ever detecting them directly. The cosmic neutrino background is a powerful and beautiful testament to the universe's hidden realities, a profound reminder that the cosmos is filled with things we cannot see or touch, but whose undeniable presence is nonetheless written into the very fabric of existence itself. They are the silent, invisible, and ever-present witnesses to the first second of all creation. Their long and lonely journey, a quiet and unbroken thread that connects the present moment all the way back to the very dawn of time. And amidst all of these great and beautiful successes of the Big Bang model, there are still small, nagging, and fascinating puzzles that continue to intrigue and challenge scientists. One of the most persistent of these is known as the cosmological lithium problem. The theory of Big Bang nucleosynthesis, which describes the formation of the first elements in the universe's first 3 minutes, makes incredibly precise and testable predictions for the abundance of these first light elements. For hydrogen and for helium, these predictions match our observations of the ancient universe with breathtaking and beautiful perfection. But for lithium, the third element created there is a small but persistent discrepancy. When we measure the amount of lithium in the oldest stars, the universe appears to have about 3 times less of it than the theory predicts it should. The reason for this missing primordial lithium is completely unknown. It could be that our understanding of the complex nuclear physics of the early universe is still somehow incomplete. Or it could be that unknown astrophysical processes in the very first stars have managed to destroy some of this primordial lithium in ways that we do not yet understand. It is a small but significant crack in an otherwise beautiful, elegant, and robust theoretical edifice. It is a quiet and humbling reminder that our grand story of the cosmos is not yet complete, and that nature still holds deep and beautiful mysteries that are patiently waiting to be solved. These faint and ghostly echoes from the dawn of time, the gravitational waves, we are still patiently searching for the neutrinos. We can barely infer the elemental puzzles we have yet to fully solve. These are the true frontiers of our cosmic knowledge. They are the faintest whispers from the very edge of time, the subtle and delicate signals that carry the deepest and most profound secrets of our own origins. To study them is to engage in a kind of cosmic archaeology, to patiently and carefully dig for the oldest and most precious artifacts of all creation. It is a slow, patient, and often frustrating process, but it is a process that is driven by one of the most powerful and noble of all human impulses, the simple and profound desire to understand where we came from. Let these gentle, beautiful, and as yet unanswered questions be a source of deep and profound peace for you now. You do not need to solve them. You do not need to understand them fully. You can simply rest in the calm and quiet presence of the mystery itself. The universe is a place of boundless wonder, not just because of what we know, but precisely because of what we do not. The very existence of these open questions is a beautiful invitation to curiosity, a quiet promise that there will always be more to explore, more to learn, and more to dream about. Let your mind be like a quiet radio telescope pointed out at the vast, silent, and starlit cosmos, listening not for a definitive answer, but for the gentle, steady, and beautiful hum of the mystery itself. And in that quiet and open state of listening, in that gentle state of boundless wonder, may you find a deep, profound, and truly restorative rest. And so our long and gentle journey back through the mists of time to the very dawn of our universe finally comes to a quiet and peaceful close. We have drifted together through moments of unimaginable heat and breathtaking density. We have witnessed the silent and miraculous unfolding of space and time itself, and we have watched with a sense of wonder as the first particles, the first atoms, the first stars, and the first galaxies slowly and gracefully emerged from the primordial luminous fog. We have seen a universe that was once perfectly simple become beautifully and infinitely complex, a universe that was once profoundly and completely dark become filled with a brilliant, dazzling, and life-giving light. And in tracing this grand and magnificent cosmic lineage, from the very first instant of creation to the present moment, we arrive finally and inevitably back at ourselves, resting quietly and peacefully in the stillness of the now. For the story of the early universe is not some distant, abstract, and impersonal tale. It is your story. It is our story. It is the most personal story there is. The very atoms that make up your body, the physical substance of your being, were forged in the heart of this grand and ancient cosmic history. The hydrogen atoms in the water that fills your cells, that gives you life, are the very same hydrogen atoms that were created in the first few moments of the Big Bang. They are a substance that is nearly 14 billion years old, a direct physical and unbroken link to the first moments of all creation. The heavier elements that make life possible, the carbon that forms the elegant backbone of your DNA, the oxygen you are breathing in and out in this very moment, the calcium that gives strength to your bones, the iron that flows in your blood, all of it was painstakingly cooked in the fiery nuclear furnaces of the first generations of massive stars, and then scattered like precious seeds across the vastness of the galaxy in their spectacular, beautiful, and dying breaths. You are not just living in the universe. You are in the most literal and profound sense the universe itself made manifest and self-aware. You are stardust, given the precious gift of life, and then given the even more remarkable and mysterious gift of consciousness, the astonishing ability to look back at the distant stars and to recognize with a sense of awe and belonging your own cosmic origins. This breathtaking journey from the almost perfect simplicity of the Big Bang to the unfathomable complexity of a living, breathing, and thinking being is the great and beautiful miracle of the cosmos. It is a story of emergence of pure and boundless potential, slowly and patiently unfolding over vast and almost unimaginable stretches of time. It is a story of profound and unbreakable connection. A story of how the smallest and most fleeting quantum flicker can eventually become a magnificent galaxy, of how the violent and beautiful death of a distant, ancient star can provide the essential raw materials for a new world and for new and wondrous forms of life. There is a deep and profound sense of peace to be found in this understanding, a comforting feeling of being an intrinsic and meaningful part of something vast, ancient, and beautiful. You are not separate from the great cosmic drama. You are a single perfect wave in its great and silent ocean, a single unique note in its long, beautiful, and unending song. As you lie here resting in the stillness, Letting the final words of this long journey wash gently over you, let this deep and powerful sense of connection be your final peaceful thought. Let it be a gentle and secure anchor, holding you in a state of perfect peace and profound stillness. The universe has been patiently working for billions upon billions of years to bring you to this very moment, this quiet, simple, and precious moment of rest. All the cosmic chaos, all the brilliant fire, all the relentless expansion has led to this: a quiet and settled mind, a resting and comfortable body, a gentle and rhythmic breath. You are the universe's way of experiencing its own quiet beauty, of knowing its own profound mystery. And now, as you prepare for sleep, it is time for the small universe within you to find its own deep and restorative rest. Let your thoughts of quarks and galaxies, of dark matter and ancient light begin to gently fade away. Let them dissolve like grains of sugar in warm water, leaving behind only a feeling of gentle and profound sweetness, a lingering sense of quiet and boundless wonder. There is nothing more you need to know tonight, nothing more you need to do. The story is told. The journey for tonight is finally over. All that is left for you now is the soft, welcoming, and peaceful silence of sleep. Allow yourself to sink gracefully and completely into that silence, to let go of the day, to let go of all your thoughts, and to simply peacefully be. Rest now. Rest deeply in the knowledge that you are held securely and lovingly by a universe that is both infinitely vast and intimately, inseparably a part of you. Rest in the profound peace that comes from knowing your own true place in this grand, beautiful, and ongoing story. If by some small chance you are still awake, you are welcome to listen to this story again, or to let the next journey begin when you are ready. But if your eyes are heavy and your mind is still and quiet, then there is nothing left to do but to let go completely. Sleep well, and may your dreams be filled with the quiet, gentle, and ancient light of a billion distant stars. As our long journey through the dawn of time comes to a gentle rest, let us pause for a moment, not to learn another fact, but to feel what this story leaves behind in the quiet spaces of our hearts. The story of the universe's beginning, while vast and cosmic, is also a deeply human one, filled with quiet lessons that whisper to us about our own lives. Please know that the reflections that follow are offered in this same spirit of gentle exploration, as a story for educational and inspirational purposes, a soft and quiet way to find a deeper peace before you drift into sleep. Perhaps the first and most gentle lesson the early universe offers us is the profound beauty of patience. For hundreds of millions of years, the cosmos existed in the cosmic dark ages, a state of profound and unbroken stillness. There were no stars, no light, only a vast, silent ocean of gas, slowly, patiently, and invisibly gathering in the dark. The universe was not in a hurry to create its first light. It trusted the slow, inexorable work of gravity. It understood that some of the most beautiful creations require a long and quiet period of unseen preparation. In our own lives, we often feel a pressure to bloom instantly, to shine brightly at all times. We grow restless in our own dark ages, those periods of quiet waiting, of uncertainty, of feeling that nothing is happening. But the universe reminds us that these times are not empty. They are times of gathering, Beneath the surface, in the quiet darkness of our own being, we are slowly pulling together the experiences, the strengths, and the wisdom we will need for our next chapter. The universe whispers that it is okay to be in the dark. It is okay for growth to be slow and unseen. Trust the gentle gravitational pull of your own journey. The light will come not when you force it, but when the conditions are perfectly patiently right. And when that light does come, this story reminds us that we are all profoundly and beautifully interconnected. We learned that the very atoms in our bodies, the hydrogen and the helium, were forged in the first few minutes of the Big Bang, and the heavier elements in the hearts of ancient long-dead stars. You are not a separate, isolated being, adrift in a cold and indifferent cosmos. You are a part of the whole. You are woven from the same thread as the most distant galaxies. The universe is not something that is happening out there. It is something that is happening in here, within you. This sense of connection can be a powerful and comforting anchor in moments of loneliness. When you feel small or separate, remember that an unbroken lineage of matter and energy flows from the very first instant of creation directly to you, resting here now. You are a living, breathing piece of cosmic history, a way for the universe to know itself. And just as the cosmic web connects all the galaxies in a vast invisible network, so too are we connected to each other, to this planet, and to the stars by silent unseen forces of shared origin and shared destiny. You belong here. You are as much a part of this story as any star in the sky. The universe also teaches us about the transformative power of chaos. Its beginning was not a gentle, peaceful unfolding, but a moment of unimaginable heat density and violence. It was a time of creation and annihilation, a battle between matter and antimatter. And later, it was the explosive death of the first stars that seeded the cosmos with the elements necessary for life. From the most violent and chaotic events, the greatest beauty and complexity emerged. In our own lives, we often fear the moments of chaos, the disruptions, the endings, the losses. They feel like destruction, but the universe suggests that these moments can also be crucibles of creation. It is often in our most challenging times that we forge our greatest strengths, our deepest compassion, our most resilient sense of self. Like a supernova, a painful ending can scatter the seeds of new beginnings, enriching the soil of our lives for future growth. The story of the cosmos whispers a reassuring truth. Do not fear the fire, for it is in the fire that the most precious elements are forged. The most beautiful structures are often born from the most chaotic of beginnings. And finally, the universe invites us to find peace in the great and beautiful mystery of it all. For all that we have learned, for all the elegant theories and breathtaking discoveries, we are still surrounded by profound and unanswered questions. We do not know what came before the beginning. We do not know what dark matter is. We do not fully understand the nature of time itself. And in this not knowing, there is a profound gift. It is the gift of wonder. It is the freedom that comes from accepting that we do not have to have all the answers. Life is not a puzzle to be solved, but a mystery to be lived, a journey to be experienced. When we let go of the need to control and to know everything, we open ourselves up to a state of quiet and gentle awe. We can look up at the night sky, not with the anxiety of an unsolved problem, but with the peaceful curiosity of a child. We can rest in the knowledge that we are part of something so vast, so beautiful, and so mysterious that it will forever inspire us to learn to dream and to wonder. So, as you lie here, let these gentle lessons settle into your being. Let the patience of the universe slow your breath. Let its profound interconnectedness soothe any feelings of loneliness. Let its story of creation from chaos bring a sense of hope to any struggles you may face. And let its great and beautiful mystery be a final, gentle lullaby for your mind. There is nothing left to figure out. There is nothing left to do. There is only this moment of quiet, peaceful rest, held safely in the heart of a universe that has been preparing for you for an eternity. Sleep well now, sleep deeply, and let the gentle starlit mystery carry you into your dreams.